The sine rule. So when we have a non-right angle triangle and we are trying to find an angle or a side, we can use either the sine rule or what we'll look at in the next video, which is known as the cosine rule. So this video is going to focus on the sine rule. Okay, so here is a non-right angle triangle. So obviously a triangle has 3 sides and 3 angles. And what we want to do is start off by labeling one of the angles as a capital A. And then we label the side that is opposite that angle as a lowercase a. Then we choose another angle and we label it with a capital B. And we choose the side that is opposite that angle as lowercase b. And then we take the last angle and we label it as angle C. And we label the side that is opposite that angle as lowercase c. Then we need to choose our formula. So this is the formula that's given to you in the formula book. Lowercase a, or side A, divided by sine of angle A, is equal to lowercase b, or side B, divided by sine of angle B, is equal to lowercase c, or side C, divided by sine of angle C. Or we can flip this formula upside down with the sines and the angles as our numerators and the sides, or the lowercase letters, as our denominators. So this is the formula given in the formula book, but it can easily be flipped upside down. And we can find this formula on page 16 of the formula tables. Now very, very, very important to note, if you're solving a triangle and you know an angle and the opposite side, use the sine rule formula. So if we're solving a triangle and we know an angle and its opposite side, so if we already know these, if we know the angle and we know the opposite side, so for example, if we knew what this angle was and this side length was, we'd use the sine rule formula. We need to learn this off by heart. Okay, so here we have a triangle. It's not right angled, so we're not going to use Pythagoras' theorem or SOHCAHTOA, because we only use those with right angle triangles. And we have angle A is 30 degrees, angle C is 50 degrees, the side BC is 12, and the side AB is labelled as X. We want to find X, the distance from A to B. Give your answer to 2 decimal places. So if we're looking for a side, the sides go on top. So looking for a side, the sides go on top. So we have A over sine A equals B over sine B equals C over sine C. So the lowercase letters are all the sides, and the sine and the capital letters are the angles. Okay, so this triangle happened to already be labelled as A, B and C, but if it wasn't, then you would label it as such. So capital A, capital B, capital C. So since this side here, side BC, is looking across at angle A, which is 30 degrees, we're going to label the 12 as lowercase a. And then since this side here, that's labelled as X, is looking across at angle C, we're going to label this side as side C, lowercase c. And since this side, AC, is looking across at angle B, we're going to label this side as lowercase b. So then we just substitute into our formula. So we're going to swap side A for 12, and that is divided by sine A, which is 30 degrees. And that is equal to, so we have side B, which we do not know. It's not labelled as X, it's not labelled as 12, so we're going to just leave it as side B. And that is divided by sine of angle B. So sine of angle B is up here. Now there's nothing labelled, but we know that this is 30 and this is 50, and angles in a triangle all add up to 180 degrees. So 180 minus 30 minus 50 leave us with 100 degrees. So angle B is going to be 100 degrees. So sine of B becomes sine of 100. And that's equal to side C, which is x, divided by sine of angle C, which is 50 degrees. Okay, so this is our sine rule formula, and this is what we've substituted into our sine rule formula. Okay, so we have 12 over sine of 30 degrees, b over sine of 100, and x over sine of 50 degrees. Okay, so we're looking for x, so x has to be part of our formula, so we're definitely going to use this fraction here, this part of our formula. And this fraction over here has a numerator and a denominator, so we've got values for both. But in the middle formula, we have b, and we don't know what b is, and we're not looking for b. So we can actually cross this out. So when we're using the sine rule formula, we'll actually only ever use two of the ratios. So we might use a over sine A and b over sine B, or we might use b over sine B and c over sine C, or we might use a over sine A and c over sine C. So it depends on what information we have once we've substituted into the formula. So since we have b and we're not looking for b, we're not going to use this one. So we're going to let these two equal each other. So we have x over sine 50 is here, and that's equal to 12 over sine 30. Now it doesn't matter which way around you have these, so this could have come first, this could have come second. Okay, so now we want to solve for x. So we want to get the x on its own, so we're going to cross multiply. So it's going to be x multiplied by sine of 30 degrees, so we get x sine 30 degrees, is equal to 12 multiplied by sine of 50 degrees, so 12 sine 50 degrees. Very, 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 very important that the 12 goes in front of the sine 50 degrees. Because if you put it the other way around, if you had sine 50 degrees times 12, then what would happen is it would multiply the 50 by the 12, and then it would apply the sine function. Whereas we want 12 multiplied by sine 50 degrees. So the 12 has to go in front. Okay, so we have x times sine of 30 degrees, but we want x on its own. So we're going to divide by sine 30 degrees so that they will cancel out and leave us just with the x. But if we divide by sine 30 degrees on the left of the equal sign, we must divide by sine 30 degrees on the right of the equal sign. So we'll end up with 12 sine 50 degrees divided by sine 30. So we get 12 sine 50 degrees divided by sine 30. And into the calculator and round it off to 2 decimal places, we get 18.39. So we were asked to find x, which is this distance here from A to B, and we got it to be 18.39. Okay, so now we have another non-right angled triangle. And remember, if we have a right angled triangle and we're trying to find a missing length, we use Pythagoras' theorem if we have the other two lengths. And if we have a right angled triangle and we're trying to find an angle, or we're trying to find a side and we're given angles, we use SOHCAHTOA. But we do not have a right angled triangle, so we use the sine rule or the cosine rule. And in this case, because we have an angle and we know the opposite side, we're going to use the sine rule. So here's our non-right angled triangle. Angle A is 30 degrees. Angle C is just labelled as angle A. We do not know what the angle is. That is what we're trying to find. The side BC is labelled as 10, and the side AB is labelled as 15. So find the value of A. So find this angle. Give your answer to the nearest degree. So when we're looking for an angle, the angles go on top. So we're going to use the formula sine of angle A divided by A, side A, is equal to sine of angle B divided by side B, is equal to sine of angle C divided by side C. Now, to be totally honest, if you were to use the other formula, which had the sides on top, it wouldn't really make much difference because you're still going to cross multiply and solve this time for A instead of X. So you don't have to necessarily use this formula, but it's an easy formula to get because you just flip the formula that we're given upside down. Okay, so the first thing we're going to do is label our triangle. This triangle has already been labelled as A, B and C. But if it wasn't, you would label it as capital A, capital B, capital C for the angles. Okay, so if this is angle A, then the side looking across at angle A is going to be side A. So I'm going to label 10 as lowercase a. And we've labelled this as angle C, so we're going to label the side looking across it as lowercase c. And this is angle B, so we're going to label the side looking across it at lowercase b. Okay, so in the last question we were able to work out the other angle, the third angle of our triangle. But in this question we only know one of the angles, so we can't add them together and take them away from 180 to figure out the missing angle. So we don't actually need to do that in this question. Okay, so now we're going to substitute into our formula. So sine of angle A is going to become sine of 30 degrees. That's going to be divided by side A, which is 10. And that's all equal to sine of angle B, which we don't know, so we'll just leave it as sine of angle B, divided by side B, which we don't know either, so we just call it B. And that's equal to sine of angle C, which is going to be sine of angle A, divided by side C, which is going to be 15. Okay, so we're looking for the value of A, so we're looking for sine of A. So this is like sine of X really. We're looking for sine of A. So we have sine of 30 divided by 10, so we're definitely going to use this ratio. We're looking for sine of A, so we have to definitely include this ratio or this fraction. And we've sine of angle B, which we do not know, divided by side B, which we do not know. So we're not going to use this ratio. We're not going to use this fraction. Okay, so we're going to have sine of 30 over 10 is equal to sine of A over 15, or else sine of A over 15 is equal to sine of 30 over 10. Doesn't matter which way we put it. Next, we're going to cross multiply. So we're going to do sine A times 10. So we're going to have 10 times sine of A, make sure the 10 comes in front, is equal to 15 times sine of 30. Again, make sure the 15 is in front. So we have 10 times sine A is equal to 15 times sine 30. So we want to get the sine A in its own, so we're going to have to divide by 10 to get rid of the 10 in front, so that will cancel out that 10, leaving sine A on its own. But if we divide by 10 on the left of the equal sign, we must divide by 10 on the right of the equal sign. So get 15 times sine of 30 all over 10. So make sure you have it as a fraction divided by 10. Because if you just wrote into the calculator divide by 10 and you put it on to the end of the 30, it would end up dividing 30 by 10, which would be giving you sine of 3. So we don't want to do that. We want 15 times sine of 30 all over 10. So putting that into the calculator, it'll give you 0.75. So we need to find the angle, because we do not know the angle, and we don't know the angle, we have to use the inverse. We have to use the shift or second function button. Press sine, and sine minus 1 should come up. So the inverse, sine minus 1 is known as the inverse of the sine function. So we can press sine minus 1, a bracket will come up, put in 0.75, close the bracket, press equals, and we get 49 degrees to the nearest degree. Or we could have pressed sine minus 1, a bracket would have opened. We could have pressed the fraction button and put in 15 times sine of 30 as our numerator, divided by 10 as our denominator, close the bracket, and then press equals. Make sure that you always close the bracket whenever you're using sine or cosine function, or it will not work. It'll come up as an error on your calculator. So we were asked to find the value of angle A, which is this angle here, and it works out to be 49 degrees.